Okay, so question one. We've got this triangle, side 7, 5 and 8, and that angle there, theta. And we want to show that the angle theta is 38.2 to the nearest 0.1. How do I do this? Can someone talk me through this? How do they find out the value of that angle there? Cosine rule. And what is the cosine rule? A squared equals b squared plus c squared. That's just Pythagoras. And then you take away the 2bc cos a. Okay, that's in the formula, I believe. Okay. 2b, oh, yes, sorry. 2bc cos a, right? Cos a. Okay, now, just because the triangle in the diagram is labelled up ABC, that doesn't mean anything. You label it up however you want. So if you're using the cosine rule, which angle is going to be the A? Guys, if you try to pay attention while I'm doing this, right? This angle here is going to be the A. Okay, so this side is the A side. And does it matter about the other sides? No. If this side is B, then this angle would be B. And if this side is C, then this angle here would be big C. Okay, so we want to find out the value of theta. So I've got to rearrange this. Okay, who can do that for me? Seb, do you want to have a go at that? Can you rearrange that for the angle? Yeah, I'll just write it out, yeah. It's cos A minus A squared all over 2bc. I think you might be right. Okay, so just rearrange that. And so now I'm just going to put in the values, okay? So the theta value that we want is going to be cos to the minus 1, the inverse cos function. What was b? B was 7, so it's going to be 7 squared plus 8 squared, take away 5 squared, all divided by 2bc. Well, that's 2 times 7 times 8. 7 times 8, what's that, 56? And then times it by 2, is that 112? Wow, I'm getting good. Okay, so it's theta. And what do we need our calculators in, radians or degrees? Degrees. Okay, so 7 squared is 49, 8 squared is 64, and that's take away 25, and it's all over 112. So I'll just put it in our calculators. Let's just tidy this up. Cos to the minus 1, 49 plus 64, what's that? 113, is it? And then take away 25. Is that 88? I made that up. It is 88. 88 over 112. Okay, so I just grab my calculator and I make sure it's in degrees, which this one is. Make sure it's in the right mode as well. And I'm doing inverse cosine of 88 over 112. I could have put it in my calculator a while back, I guess. 38.2. Okay? And that's what you wanted, isn't it? Everyone happy with that? Who managed to do that? What formula do we use for the area? So the area of a triangle is half AB sine C. So this time I'd have to relabel up the triangle again, but I think you should be able to see that the area we want is going to be 1/2. The A is just going to be the 7, isn't it? The B is just going to be the 8, and then it's going to be sine of the angle we just got, 38.2. Okay, so I just put all this in. This is going to be 28 times sine 38.2. So just put this in the calculator, and that. Sine of 38.2, and then times it by 28. Is that right? 17.315. Is that right for the area? Anybody? Yeah? Yeah? 17.3 then, should we put? Okay. And what's the units? Centimetres squared, okay. So question 2, it says write down the value of n given that, and let's just put this down, given that y over x to the 4 is equal to x to the n. Okay? So, anybody tell me? Yeah, n is just x to the minus 4. Okay? Because I can write this thing on the left as x to the minus 4. So n equals minus 4. That's all you've got to do for that one. Okay? 1 mark. Okay? Now for the second bit, we want to do the expansion of 1 plus 3 over x squared squared. Okay? Now hold on a second. When I first looked at this, I thought it was a binomial expansion. Do you have to do it by binomial expansion? No. Where's the binomial expansion question then? What? I didn't look at the power when I looked at it before, so all we have to do is expand this out. Now you can use binomial expansion. I think you do need to learn it for your exam, or you can just multiply it out because it's only to the power 2. Okay? So I think I'm going to do it using binomial. Well, you wouldn't be able to tell which way I've done it. So anyway, we're going to get 3 over x squared squared. Do you agree with that? Plus what? 2 lots of 3 over x squared. Do you agree with that? Plus 1. So this is going to be 9 over what? What's it going to be? 9 over what? X to the power of 4. And this is going to be what? 6 over x squared. And this is just going to be 1. Okay? Everyone happy with that? So that's B done. Okay? Now, it then says for C, hence integrate this. Well, we couldn't have integrated 1 plus 3 over x squared to the power of 2 without expanding it, but I can integrate this, can't I? The question's asking you to integrate 1 plus 3 over x squared squared with respect to dx. We've shown that that's the same as this 1 plus 3 over x squared x squared to the power of 2. We've shown that that's the same as this, so that's the same problem. No, I'm just writing it on here so that it's clear. What's the best way to write this so I can integrate it? What's the best way to write that so I can integrate it? 9 over x to the power of 4. When I integrate things, it's best to write it 9x to the minus 4, yeah. And this one, 6x to the minus 2, and then that's just plus 1. So, can I get someone to do the integration then, please? What about Kat? Can you do this? How does the integration work, right? Add 1 to the power, so it's now going to be 9x to the power of... And then what do I do? Divide by the new power. Okay, and the next one then? (6x to the minus 1) divided by minus 1. And what happens to the 1? Just goes to x, yeah? And what else? Plus c. Okay, and what I'm going to do is just tidy this up a little bit. Okay, so is there a better way of writing the first term? Callum, do you want to do that? Can you just tidy this up a little bit? How could I write that first term a little bit better?
Minus 3x to minus 3.
Yeah, I'm going to write it as minus 3 over x cubed, I think. Okay?
Minus 6 over x.
Yeah. Plus x plus c. Is everyone happy with that? Any questions on that one? I wouldn't have thought you would have to rewrite it like that. I'm just going to do it because I'm going to sub the values in. Okay? So the final question, part D, it's asking you to integrate the same thing we just integrated, but this time it's a definite integration. There's some limits on it. So I've got 1 plus 3 over x squared to the power of 2. And we've just shown that this should be the same as all of this that we just worked out. So all of that. Do I need the plus c now? No, it's going to go when I do the definite integration. I'm going to put the limits in 3 and 1. Okay? So the first thing I'm going to do is sub in 3. If I sub in 3, what does this first term become? If I sub in 3 into there, what do I get? If I sub 3 in there, what do I get? Minus 3 over 27. If I sub 3 in there, what do I get? Guys, if I sub 3 in there, what do I get? 2. And if I sub 3 in there, I just get 3, right? Okay. And then I'm going to sub 1 in. I'm going to take away when I sub 1 in. When I sub 1 into the first term, what do I get? Minus 3. When I sub 1 into here, what do I get? Minus 6. And when I sub 1 into here, I just get 1. Okay? So that's where I'm at. And I'm just going to tidy this up and I should be done. Minus 3 over 27, what's that? Minus a ninth. So this is minus a ninth. And then I've got minus 2 plus 3, that's 1. And I'm going to take away, what have I got over on this side? Minus 3, minus 6, that's minus 9, minus 8. All this thing on the right equals minus 8. Do you agree with that? No. And it's minus 8, but it's take away minus 8, so it's going to be plus 8. So this is 1 here, plus 8. So I think that's minus a ninth plus 9. Do you agree? Okay. Which is going to be what? And it wants the exact form, doesn't it? This is the same as 8 and 8 ninths, isn't it? So how could I write that as one fraction? Say again? 80 over 9. Okay. Brilliant. Any questions on that one? I think that's okay, isn't it? We've got a sequence defined by u n plus 1 is equal to k times u sub n plus 12. Okay, and k is a constant. Okay, so the first question is show that k equals 0.75 when we've got u1 equals 16 and we've got that u2 equals 24. Who can talk me through how to do that? Chloe, do you want to have a go at that? Yeah, how do I do that? Yeah, brill. So this equation here says un plus 1 is equal to kun. So I could say that u2 is equal to k times u1 plus 12. And then I could sub in my values here. And I get that 24 is equal to k times 16 plus 12. And then I'm going to rearrange this for k. So 24 take away 12 is 12. So I've got k times 16 is equal to 12. So k is 12 divided by 16. And this will cancel down to 3 over 4, won't it? Which is 0.75. Okay, everyone happy with that? Okay, next part. Find the value of u3 and u4. Well, that should be quite easy now, because we've got the equation still. The equation is un plus 1 is equal to k times un plus 12. If I want u3, it's going to be 0.75 times u2 plus 12. And I know what u2 is because it tells me. So u3 is 0.75 times 24 plus 12. Okay, so 3/4 of 24 plus 12. Okay, what's 3/4 of 24? 18, right? Okay.
Why is it 18?
Right. And then we add 12, right? So this is u3 equals 30, is that right? Brilliant. Okay, and then I do the same thing again, and I say that U4 is 0.75 of 30 plus 12. What's 3/4 of 30? Yeah, and then I add 12, so what do I get for U4? What do I get for U4? Somebody, quickly. 34.5. So that's U4, and that was U3. Right, now, the last part of the question, I imagine that some of you didn't do too well at this, because this is something that, in my experience, people forget how to do. Okay, we've got this expression for how to find the next term in the sequence, and it says that this one here tends to a limit. Okay, Callum, quiet a sec. So you can see just from the first few terms, the first term was 16, then the next one was 24, then the next one was 30, and then the next one was, what was it, 30, 34.5. So every time we do this thing, we're adding a little bit less, aren't we? Okay, so after a while, we're going to be adding on essentially 0. So it's going to get to a point where we put something in, we add on essentially 0 and we get something out, and then we add on essentially 0, but even smaller, and we get something out. And after a while, it's going to, as the n value goes up to infinity, as n gets very big and tends to infinity, then we should just keep getting out the same thing. Does that make sense? Okay. First of all, what does it look like it's tending towards? Started off at 16, then the next one was 24, then 30, then 34.5. What's it getting closer to, does it look like? Just a guess, I'm not asking for a question. Maybe 50, 40 or 50, something like that? Okay. So when n gets very big, we should be putting a number into it. We should be getting to a point where I put a number into it, add on 0 and get, essentially, and get the same number out. Okay. Which means that the number I'm putting in is the same as the number I'm putting out. Okay. The number I'm putting in is the same as the one I'm getting out. After a while, that's what's happening. So what you want to do is, if you're trying to find the limit of this, then you make the limit, you call that the limit, should be the same as what you put in. Does that make sense? So what you put in for un, L, is the same as what you get out. And that's the trick there. Whatever I put in, L, should be the same as what I get out, L. That's the equation.
Every time.
Yeah, when it goes to a limit, what you put in should be the same as what you get out, because that's the point of the limit. It doesn't change after a while. Okay? That's always the trick there. Is everyone happy with that? And then, so that's your 1 mark, and then hence find the value of L is just solve this. Well, sorry, I should have done one more thing, Shanice. That's not quite the equation, is it? Because we know what K is. So I should have written it like this. Okay? So that's the equation that we, for the limit. So L equals 0.75 L plus 12. How do I actually find the value of L? You could do. I think the easiest way, for some reason people tend to struggle actually solving this. It's quite an easy thing to solve. Always the same really. Take 0.75 L off L, and that means that over here I will have 0.25 L is equal to 12. Can you see what I've done there? I had 1 L on the left, take away 0.75 L, so I've left with 1/4 L, then times by 4, I think you're right about that. So L equals 48. So actually it was getting closer and closer to 48. Okay, and that's the limit. So Trapezium rule, it's used for approximating the integration. What does the integration of this tell you? What is it? If you could integrate this, it's the area under the curve between 0 and 6. I'm going to pop that on here. So we want the area between 0 and 6. Okay, we want that area. Now that thing there, x cubed plus 1, all square rooted, is too difficult for you guys to integrate. Okay, so we're going to use a numerical method, and the numerical method is called the Trapezium rule, and it'll give us an approximation. Okay, so what we're going to do is it says, can we split this into 3 strips? So there's my 3 strips, 3 equal strips. What are the coordinates of these strips going to be?
2 and 4.
2 and 4. Brilliant. What's the width of each strip? 2. So I'm going to put my h value is going to be 2. That h is that distance there. Okay? And then what you do is you just put it into the formula. Okay? Now what in your formula books there's a formula for the trapezium rule, and it's, let me just write it down. It says if you want to try and integrate something between b and a, and you can't do it, then it's approximately equal to, that's the approximate there, 1/2 of h times by y0 plus yn, like that, and then it's 2 lots of all the other bits. So plus 2 lots of y1 plus y2, like that, and you keep going all the way to the end, plus y to the n minus 1, because you've already got. Okay, so let's just have a talk about what all that means. Okay, so what I'm going to do is, I'm going to make a table, is probably the best thing to do. I'm going to do this 2 ways, in fact. So I'm going to write down x values, x0, x1, x2, and x3, I think. And these x values are these x values, x0, x1, x2, and x3. Okay? So what's x0? 0. And what's x1? 2. And what's x2? 4. And what's x3? 6. And each one of these will give us a y value. So I'm going to write down y0, y1, y2, and y3. And that's what we're going to put in our formulas. And this is just saying, this is the equation we're using up here. When x equals 0, what do I get? I get the square root of 1, which is 1. Okay, when x equals 2, I get 2 cubed, which is 8, plus 1, which is 9, square root it, so that's going to be 3. When x equals 4, I get 4 cubed. What's 4 cubed? 64. I add 1, that's 65. So this is going to be root 65. Okay? And when x is 6, I get 6 cubed plus 1 square rooted. And what's that? Someone tell me? Say again? 217 with the 2. Root 217, yeah. Okay? And then all I do is I just put everything I know now into this formula, and that's the answer. Okay? That's all you've got to do. Okay? So what I'm going to do is I just do write out the area that we want. It's going to be 1/2 of h. Now what was h? 2. Okay? And then I times it by y0, which is 1, plus the last one, that's plus root 217. And then plus 2 lots of all the other ones. Well, this is just 2 lots of 3 plus root 65. Okay? And I've got that all in my calculator, so let's just do that. 1/2 times 2 is just going to go, isn't it? So all I have to do is just basically add 1 plus root 217 plus 2 lots of that. So let's just do that. So I'm going to do 3, oh, hold on. I'm going to do 3 plus root 65. I'm going to double it, times it by 2. I'm going to add on 1. I'm going to add on root 217. And that's my answer. Okay? That's the area under the curve, approximately. Okay? 37.86, shall we say. Does it say to how many decimal places we want it? 4 significant figures. So what we're saying is, the integration between 6 and 0 of the square root of x cubed plus 1 dx is approximately equal to, and it wants it to 4 sig figures. Well, what's 4 sig figures on there? 37.86. Yeah. What do you think of that question? That should be the easiest thing on the paper, really. But if you've got a calculator, grab it now. Grab it out. And I don't think it matters if it's one of these silver ones or not. But if you go to mode, click on mode. Okay. Now, I don't know if you've got this or not, but there'll be an option that says table. You got that? Okay, click on table. Has everyone got it? Okay, what you want to do now is be very careful, but write in the equation. So it's the root of, I'm going to have to do this in brackets, was it x cubed? Yeah? Well, the x you do by pressing alpha and x. Okay? Okay, and then you want to cube it, like that, and then we plus 1, right? Everyone try and write that in. That's okay now, it's all on the thing. Has everyone done that?
Where's function x?
Where's that? It's on table mode. Is everyone happy? Everyone not managed to do it? Okay, I don't think it matters which calculator you got, as long as it's one of those things. Right, press equals, and you get a new thing. It says start. It's asking you where you want to start from. For this question, where does it want you to start from? 0. Okay, so put in 0. Where do you want to end? 6. And now it's asking you about the steps. How big do you want the step to be? 2. Okay.
I do.
Why is that?
Yeah, put a bracket on the
Oh, is it because I'm not close the brackets? Let's try that again. Equals. Start at 0, yeah. Finish at 6. Step 2. Right. Now, look, these are the x values. 0, 2, 4. Let me just move this over to the side. 0, 2, 4, and 6. And on the right-hand side, you'll have the y values. 1, 3, root 65, and 14.73. Okay? So if you're not too sure about sorting out all those y values, the calculator just do it like that. Okay? All you've got to do then is take those y values and put them in. Okay? The next bit of this question, looking at it, I think you've gone from perhaps the easiest question on the paper to what I think is probably the hardest question on the paper. Okay? So I'm quite interested in who's done this, because I think this is difficult. It says the curve with the equation, well, it's the curve with the equation, the thing we just did, x cubed plus 1, is stretched parallel to the x-axis, scale factor of a half. What's the new equation? I think this is what's happened, okay? It's stretched in the x direction, scale factor of half. Now if it's in the x direction, that scale factor of half is the opposite of what you think, isn't it? Okay, so I think the new equation is this. Still got square root on. I think it's that. Do you all agree with me? It's the x that's changed, but the x has all been cubed. So what's that the same as? 8x cubed plus 1. Okay, I don't think that's very nice at all, is it? Do you want a little picture of it? Right, I'm going to get you to do some of this, I think. The equation is y equals 15x to the 3 over 2 minus x to the 5 over 2. And the first thing it wants you to do is just differentiate it. Okay, find dy dx. So, do I have to do anything with it before I differentiate it? Is it already in a form where I can differentiate? Yeah. Okay, right, Emily. Differentiate this for me, can you? What would I get? Yeah. Brill. Yeah. To the 3 over 2. Perfect. Okay, if you got that, you've got to do it right. Okay, and it's 3 marks. Yeah, that's quite good, isn't it? Okay. Now, hence find the coordinates of the maximum point. This thing is maximum when what? How do I find the maximum point? Okay, so I'm going to write this. I always write statements like this. Maximum when dy dx equals 0. Or sorry, I should really say stationary when dy dx equals 0. So what I'm going to do is I'm going to put the thing that you just found out to be dy dx, we'll put it equal to 0. Okay, so I've got 45 over 2 x to the half is and minus 5 over 2 x to the 3 over 2 is equal to 0. Okay? Right, who can help me out with this? What do I do first? times by 2. Yeah, okay, I can do that. I'll times by 2. 45x to the half minus 5x to the 3 over 2 is equal to 0. Right, next step.
I've changed 45x to the half into 45 root x.
You're going to change the indices to roots, right? Okay. Say again.
Divide by 5.
Divide by 5?
You can do that.
All right. Okay, we can divide by 5, and then I'll do what Sean said. So we'll divide by 5, and then we'll do what Sean said, which was we'll change these to roots. For some reason, people find it easier to solve. People find it easier to differentiate when they're indices, but find it easier to solve when they're like this. What does this one become though? This is x cubed square rooted. Is that true? Equals 0. Right, next step.
Take the x cubed.
Take this one over yet. So I've got 9 root x is equal to root x cubed. Next step.
Divide.
Ooh.
I mean,
What? This is the one I keep moaning you about, isn't it?
You can clearly see in the graph it's not going to be tangible, but it gives you what not.
You want to avoid dividing by things you don't know if they're 0 or not. So can someone tell me what the method is here? Just square both sides, right? If I square this side, I get rid of the root. Square this side. So if I square this side, what do I get? 81x. What do I get this side? Just x cubed. Cool. Okay. Now, I know what you're going to say now. Divide by x, right? What do I do? Not quite, no. I want to get the x's onto one side, but I don't divide by x. I want to do what? Can someone tell me? Yeah, sorry. X cubed minus 81x equals 0. Right. Okay, and then factorise. X squared, x minus 81. Are you happy with that? Is that better?
no. The x squared. In the brackets it's x squared minus.
Right, okay, I agree with that. So this is x here, and this is x squared in there. Cool, that's better. Right, so I'm looking. So now you should be able to tell me the values of x that make this 0. What are they? Well, if that one's 0, it all goes to 0. So when x is 0, and when x is 9. Well, plus or minus 9, isn't it? Therefore, x equals 9 is the max point. Yeah. Okay. Cool. Right. The point 114 lies on the curve. Show that the equation of the tangent has this point. So, if this point lies on the curve, how do I find the tangent? 114. Let's go back up here. 114. If we're saying the maximum is at 9, 114 is going to be like here somewhere. And I want the tangent to that. I want the tangent line to that. Okay. If I want the tangent line, I'm going to need the gradient and a point that it goes through. Now, I've got a point that it goes through, because it goes through that point. But how do I find the gradient? I've got an expression for the gradient. I've got that dy dx equals, what did we get? Dy dx equals 45 over 2 x to the half. 45 over 2 x to the half. Minus 5 over 2x to the 3 over 2. Yeah. If you sub in this value here, it's going to give you the gradient at that point. Okay. So we're going to sub in when x equals 1. Sub in when x equals 1. What do I get? If I put 1 into there, what do I get? Just 45 over 2. And if I put 1 into there, what do I get? Minus 5 over 2. Okay, so that's it. All I had to do was sub 1 in. Just put these things together. It's going to be 45. It's going to be 45 take away 5, which is 40 over 2, which is 20. Okay, so the gradient should be 20. And I know this point that it goes through, so how do I find the equation of the tangent line? It's this, isn't it? Okay, because I know 2 points that it goes through. Oh, sorry, I know a point that it goes through. So I just put that in. It goes through point 114, wasn't it? Okay, So this is going to be y minus 14 is equal to 20, x take away 1. It wants us to get it to look like that. So this is going to be y minus 14 equals 20x minus 20. So this is y equals 20x minus 6, which is what it wanted to show, right? Is everyone happy with that? Okay. Now, last question. I've got the tangent to the curve at P. So this is the tangent at P. And it says that the tangent at P intersects the tangent at M. Okay. It's just, the line's going to be flat line, isn't it? So it's going to be y equals a constant number. I just need to find out what that constant number is. So all I really need to know is, go back up to the graph here. I've just found this tangent line here. Yeah, tangent at 1. And I want to know when it intersects the tangent, grab that, there. Okay. Well, that tangent line there, it hasn't got a gradient, has it? It's got a gradient of 0. So all I need to know is just how high it is. Well, it's at 9, so if I sub 9 into here, if I sub 9 into there, it will tell me the height, and that's going to be the value there. Y equals whatever the height is, isn't it? Okay. So let's just sub 9 into there, and I'll get the equation for that. So what was y? Let's do it. So I'm going to sub 9 in, aren't I? So the equation is y equals 15 x to the 3 over 2 minus x to the 5 over 2. And I want to know what y is when x equals 9, because when x equals 9, that's that point there, and I want to know what the height is. It's got no gradient, so it's just the height. So this is going to be 15 times 9 to the power of 3 over 2. Well, that's 9 rooted, which is 3, and then cubed, so is that just 27? And this is going to be 9 rooted, which is 3 to the power of 5. So what's 3 to the power of 5? Is it 3? 243. Okay. So 15 times 27, let's just do that. I need to take it back into that mode. 15 times 27, take away 243, is 162. So the height on the graph here, this thing has a coordinate, or this point here, the maximum point, is at a height, is at a coordinate 9, and what was it? 162. 162 there. And so the equation of the tangent there, because there's no gradient, the gradient is 0, the equation of the tangent is just 162. Just y equals 162. So to find out where the two lines cross, this is the equation for the tangent at P, and the tangent at M is just y equals 162. How do I find where they cross? Yet, not even simultaneous equations, because I've only got a y value to sub in, and it's, yeah, you could do it exactly like that, but it's a bit easier than that. So I just say that 162 equals 20x, take 6, so 168 equals 20x, so that the x value is 20 divided by, sorry, is 168 divided by 20. Okay. Okay, and this is just 8.1. And then, so what I've found is that I've got this curve, like this. There's a tangent that cuts here, which we had, and we wanted to know where it cut the other tangent, and we found that that cuts at a point, or the x value, 8.1. Is it 8.4?
Yeah.
Is it? Why did I get 8.1? Have I just done some bad maths? That should be 8.4 apparently. And that's 8.4 as well. And then this point here, if you remember, has the x value of what? It was 9, wasn't it? So the distance between the two, which is what we're asked for, is 0.6. That's right, isn't it? So I've done it all right, haven't I? So the distance r to m is just 0.6. We're told the angle is 1.2 radians and we don't know what the radius is, but we do have a couple of equations that we can use, and those are that the area of a sector is what? What's the formula? 1/2 r squared theta, as long as you're in radians. And what about the length, the arc length? That's that bit there. What's the formula for that? It's just r theta. Okay, so we're told what the area is. The area, it says, is 33.75. So if the area is 33.75, then 1/2 r squared times theta, which is 1.2, has got to be 33.75. Do you agree with that? Do you agree with that? Yeah? Okay, so I'm just trying to find out what r is. Okay, so what shall I do next? Times it by 2. R squared times 1.2 equals, what happens if I do this by 2? 67.5. Yeah? Okay, next step. Divided by 1.2, brilliant. Is it? 0.25? Let's just square root it, yeah? And what do you get? 7.5. Bill, so I've got the r value, and now I've got the r value, I can find out what that length is, the arc length. The arc length is going to be r theta, so it's going to be 7.5 times 1.2, which gives me what? 9? Yeah, is that right? Okay, so now I've got the arc length and I've got the two radius. So I'll come up here, this length is 9, this length is 7.5, this length is 7.5 as well. So the total perimeter is just those things added together, isn't it? 7.5. That's all right. 15, 24. Okay, that's it. Right. Okay, for question 7, we're told the second term of a sequence and the fifth term, and it's a geometric series, which means it's getting multiplied by the same ratio every time. Is the series going? Is the sequence going up or down? Down. So what does that tell you about the r value? It's somewhere between 1 and -1. Okay. So what we're going to do, and this is usually what we do with this, we'll write down the second term as AR. So we'll say that AR equals 375. And the fifth term we can write down as AR to the power 4, and that's 81. Okay. What's the method now to find out what R is? Divide. Okay, so AR to the 4 divided by AR should be the same as 81 divided by 375. Now, if you divide, the A's are going to cancel, and we're going to lose an R on the bottom, and this is going to become 3 on the top, so we'll get R cubed is equal to 81 over 375. Now, this actually, they both have 3 as a factor in this, don't they? So if I divide the top by 3, I get 27. If I divide the bottom by 3, I get 125. Okay, can everyone see that? Okay, so now I'm just going to cube root it to find out what R is. The cube root of 27 is 3, and the cube root of 125 is 5. So this is just 3 over 5, which is 0.6. Okay, so R is 0.6. Now I know what R is. Well, we've shown that the common ratio is 0.6. Notice it tells you in part A that R is 0.6. So if you didn't get that, you can still do the rest of the question. Well, now I need to find out what A is. Well, we already know that for part 2, we already know that AR equals 375, and we just found out what R is. So A times 0.6 equals 375. So I divide it, and what do I get? It's going to be 6, what is it? Is it 625? Okay, is everyone happy with that? So the first value in the sequence is 625. The second value is 375, and so on like that. We have two sums for the geometric sequence. They're both in the formula. We have the sum of the first n terms. What's the formula for that? The sum of the first n terms. A1 minus r to the n over 1 minus r. And we also have the sum to infinity, and that's when if your value of r is less than 1 but greater than minus 1, let me write it like that. So if your value of r is greater than minus 1 but less than 1, then it means it gets smaller every time this sequence, and when I add it up I actually get to a limit, and I get something called a sum to infinity. R to the power of n will go to 0, and this whole thing will just turn into that. Okay, so the first question is, can you find the sum to infinity? Well, the sum to infinity of this sequence is going to be A, which we got to be 625, divided by 1 minus r, and 1 minus r is 1 minus 0.6, so that's 0.4. So what do I get for that? What's the sum to infinity? 1562.5. Who managed to do that? Okay. Now, the very last question is just testing whether you understand this notation. Now, part C, watch very carefully this bit, please. The nth term of a sequence is un. It's given us the sum of, this means the sum of all the terms in the sequence from the 6th term to the infinite term. Okay, does that make sense? And this is the same as, if you think about it for a little bit, the sum of all the terms in the sequence from the first term to the infinite term, take away the sum of the first 5 terms. Is that true? Just look at that and make sure it's true. The sum of the from the 6th to the infinite term in the sequence is the same as all of the terms in the sequence, take away the first 5. Is that true? Okay. Now we've already worked out the sum of the infinite terms in the sequence. That's what we just did. Okay. So the sum from n equals 6 to un, which is what we're trying to work out. This bit here is just 1562.5. That's the sum of the sum to infinity, isn't it? That's what we just worked out. So I've got to take away the sum of the first 6 terms. So how do I work out the sum of the first 6 terms? Well, I put it in the other formula, because it tells me if you want the sum of the first 6 terms, do this and change the n's to 6. So it's going to be, what was A? 625. Take away 625. 1 minus 0.6, that was what R was, to the power of 5. We want the 1 minus sum of the first 6 terms.
Yeah. 1562.38.
0.3. Yeah. Should we just do it? I'll just put that thing in the right in. 625 multiplied by 1 minus 0.6 to the power of 5 equals, and then I'm going to divide it by 0.4, aren't I? 1441 I got there. So I think this is 1562.5 minus 1441. So it's going to be 1562.5, take away that, Oh, what did I do then? 1562.5 take away 1441. 121.5. 121.5 did I say? Right, who got that? Okay, very, very good that is. This is question 8, and part A, just asking us to show that sine theta minus cos theta over cos theta equals 4 is can be changed some way to tan theta equals 5. Okay. So all we do is split this into two fractions. So this is sine theta over cosine theta minus cosine theta over cosine theta equals 4. And this is sine theta over cosine theta minus 1 equals 4. And we're going to use two identities, or you need to know two identities for the Core 2 course. One of them is that tan theta equals sine theta over cosine theta. And the other one is that sine squared theta plus cosine theta equals 1. So we're going to use both of these identities. And the one we're going to use for this first bit is that the sine theta over cosine theta can be written as tan. So this is tan theta minus 1 equals 4, and therefore tan theta equals 5. Okay. So that's part A. For part B, we're given this 2 cosine squared x minus sine x is equal to 1, and it wants us to write it in just with signs in, so we're going to use the other trig identity, the sine squared plus cosine squared equals 1, and if sine squared theta plus cosine squared theta equals 1, then cosine squared theta equals 1 minus sine squared theta. So I can just come over here and change that cosine squared there to 1 minus sine squared x. And then I still got minus sine x. And I'm going to bring the 1 over, put that all equal to 0. And then I'll just multiply this out. This is 2 times minus 2 sine squared x minus sine squared x minus 1 equals 0. So this is minus 2 sine squared x minus sine x. Minus 1 plus 2 is just going to be plus 1 equals 0. And then if I multiply everything through by minus 1, I'm going to get 2 sine squared x plus sine squared x minus 1 equals 0. And that's what you were trying to solve. Or trying to show, sorry. Okay, so that there is right. Now, you can see that there is a quadratic in sine theta. So the next question is hence solve that. Well, what I usually do here is I make a substitution. Let u equal sine x. And that means that this whole thing, you can see a lot more clearly, is just a quadratic in sine. So this is 2u squared plus u minus 1 equals 0. And then I'm trying to find the value of u that makes this true. So it's going to be 2u, and it's going to be u here, and then it's going to be minus 1 and plus 1, I think. Okay, equals 0. And that means that u equals 1 and u equals negative a half. But remember that u was actually sine x. So sine x equals 1. And sine x equals negative a half. And then I've just got to solve this. And I want to solve these here in the region 0 find all the solutions of this in the region 0 to 360. Okay, so I'm just going to draw out the sine graph from 0 to 360. Sine graph starts at 0, comes up, goes down, comes back up to there at 360. Okay, and this is 180, and this here is 90, and this here is 270, and it goes from 1 to -1, and this here is x, and this here is sine x. Okay, so what I can do is I can have a look where sine x equals 1, or sine x equals 1 there, and it doesn't equal 1 anywhere else. So it equals 1 when x is 90. So the first solution I've got is x equals 90. And I'm also looking for when sine x equals -1/2. Well, you might know this, or you can put it into your calculator by doing the inverse sine. So inverse sine, check you in degrees. Inverse sine of -0.5 is -30. Well, -30 isn't actually in my region. -30 would be, if I carried on this graph down here, -30 would be somewhere about here. So have a look at where else -30 would be, and it's going to be at 180 plus 30 and 360 take 30. So let's just have a look at what I did. I did sine to the -1 of -1/2. This is going to give me the other x value, gave me -30, but -30 wasn't in the range, so I did x equals 180 plus 30 using symmetry, and x equals 360 take 30, which equals 30. This one equals 150. So, okay, so I get 3 values of x in that region, and they are x equals x equals 90, x equals 150. I've made a mistake here. That should be 330 there, shouldn't it? And x equals 330. So it's 3 solutions. Okay, let's just do question 9. What do you think? Who's done question 9? What do you think of it? Is it easy or?
Okay.
You did quite a good job of it, Josh. I think I'm not sure about. I didn't check the first part of it. So should we do that? Find the value of p for which 125 is equal to 5 to the power of p. Who can talk me through how to do that? That's a p. How do I do that? Chloe? Put that way. How do you do that? Anybody? Not really. This is more like an index question. Yeah.
Well, you can write 125 as 5 to the power of 3.
Brill. Okay. That's exactly how you do this. 125 is 5 to the power of 3. So it's the square root of 5 to the power of 3, that is. 5 to the power of 3 is 125. So that equals 5 to the power of p. So how can I rewrite this? 5 to the power of 3 square rooted. What's that? Brill. This is 5 to the power of 3 over 2. So what's p? 3 over 2. Okay. Part B, similar sort of trick. Part 2, part 2. Similar sort of trick. 5 to the power of 2x is equal to square root of 125. Can someone just tell me what the answer to this one is? It's only worth 1 mark. Say again? Yeah, I'll go with that. If you look at the 2 questions here, you've got the same question, or just look at these 2 questions. The p in this question should be equal to the 2x in this question, shouldn't it? Can you see that? You can do the whole problem the same way as you just did it, but look, 5 to the power of something equals root 125, and here you've got 5 to the power of something equals root 125. So those two somethings must be the same. P equals 2 lots of x, but we know that P equals 3 over 2, so therefore x equals 3/4. Okay, and that's that one done. Nice marks, right? Yay. Okay, next question. It says use logarithms to solve this. So that means you do actually have to use logarithms to solve it. You can't make up your own new method. So we've got to solve 3 to the power of 2x minus 1 is equal to 0.05. 5, like that. Okay, 0.05. Can someone write that as a fraction? Because I don't really like decimals very much. I think it's 120, isn't it? 1 over 20. Okay, logs of both sides, would you agree? Take log of both sides? No? Say again.
So that's in the format of A power C for B. And rewrite it as that, and then...
It says use logarithms though, so I think...
Yeah, so if you write it log of base 3 of 20 equals 2x.
Oh yeah, I see what you're saying. I'm not going to do it that way. Okay. I'm going to take log, I'm going to do log to the base 10 of both sides. Like that. Sorry, not quite like that, because I didn't do log of that side. So I do log, whenever you're trying to find something that's in the power, you do log of both sides. So that's log of that. Okay, now, what can I do with the power here? I can bring it out the front, can't I? Do you agree? That's the point of logs. I can take 2x minus 1 out the front of there. And this is log 3. Now this one here, is there another way I can write 1/20th? That's not the question I'm asking. Is there another way I can write 1/20th? Well, yeah. I can write it as 20 to the power of minus 1. And so this 1 over 20 could be 20 to the power of minus 1. And the power is minus 1, so I can put it at the front. So it's like that, right? Okay. 20 to the power 1, and then bring the minus 1 down. Next step. Next step is divide by log 3. So I've got minus log 20 over log 3. Next step, add 1 to both sides. So I'll put the 1 at the front because this bit's minus. It's going to be nicer like that. And the final step, divide by 2 is the last step. So x equals a half minus log 20. And I'll put the 2 on the bottom, shall I? So, now if I put the 2 in front of the log, what does that mean? This is going to be 2 log 3 on the bottom, isn't it? Because I've halved it. But 2 log 3 is the same as log 9, isn't it? Okay, so I'll just write it like that. Whack that in your calculator. Let's do it. What is it? A half minus log 20 over log 9. Okay. So 0.5 minus log 20 divided by log 9. Is that what you got? Cool. So how many decimal places? Okay, what you got? No, I got that. Is that right or not?
Yeah.
I think so. Minus 0. How many decimal places? 4. So is it 0.8634? Yeah. Okay, fine. And the very last question, I know we're running out of time, but this won't actually take that long. I'll just do it really quick. We've got C, and it's log to the base A. Now there's quite a lot of different ways of doing it. The main thing you've got to do is just do one thing at a time, and then you'll pick up more marks. Okay, log to the base a of 3 plus log to the base a of 2. I'm just going to do this really quick, and if you want to watch it again, you'll have to watch it again. 2 logs in the middle. The 2 logs in the middle I can write as 1 log with the things multiplied. Do you agree with that first statement? That's going to be 2. Guys, can you just pay attention for a sec? I know. Guys, just pay attention for a sec. 2 logs in the middle I can write as 1 log, and it's going to be 3 times 2, so it's log 6. Take away 1 there. Do you agree with that? Okay. Second thing I can do is now bring that 2 in front to make it a power, so it's going to be 6 squared. So that there is going to be log 36. Take away 1. Now, this 1 here is going to be the troublesome thing, but you've got to remember that a log rule that you don't often use, but you have to remember, is that you can always write 1 as log a to the base of a. Okay, and that's the trick there. If you ever see a log question and there's a 1 in it, and that, you can write it as log to the base, whatever it is to that. And now this is 1 log 36 divided by a, because it's minus to divide them. Now I've got 1 log equal to another log, so that just means that x equals 36 over a. That's it. Okay.